Hello everyone, happy to see you here. Welcome back to my channel Olympiad Mathematics. Today we have very interesting, I would say like quick and relaxing algebra question. We know that the sum x plus y equal to 10 and a product xy equal to 12, and we need to find our x and y. If we have your solution, your answer, you can also write your solution down in the comments below, and then we will check our answer, so it will be really interesting. So this is a basic system of equation from a school algebra. We need to express from the first equation. Let's express, for example, y. As a result, what do we have? Y equal to 10 minus x. So 10 minus x. And right now, let's plug in this y into the second equation. So let's do this right now. As a result, we have x times 10 minus x. 10 minus x is equal to 12. Okay, into the second equation, we plug the thing, and right now let's simplify this. First of all, let's multiply this x by this parentheses. As a result, we have 10x minus x squared equal to 12, and this is a quadratic equation, but we need a little bit different order. Yeah, we need to this one on the first position, so let's do this. Let's write it on the first position but with a negative sign, so minus x squared plus 10x, and of course we need to subtract 12 because we need 0 on the right side, so we have minus 12 is equal to 0. Right now, let's right here, let's multiply both sides by minus 1. When we multiply both sides by minus 1, we can easily change all the signs because we need a positive sign right here, not negative. So as a result, we have x squared minus 10x and plus 12 is equal to 0. Okay, really great. Right now, according to a basic method of coefficients, we can easily solve this quadratic equation. So a equal to 1, b equal to minus 10, and c equal to 12. Really great. And the final tricky move right here, let's find real quick our discriminant, and then we're gonna plug in this discriminant into like all known spot into all known formula. So discriminant equal to b squared minus 4ac. As a result, what do we have? B squared, so minus 10 square minus 4 times 1 and times 4 times 1 and times 12. Really great. Equal to, so we have right here 100. Yeah, we have 100 minus, we have 48. So our discriminant is positive, so it means that right here we have real number roots. So this is really great. So we have 52. This is our discriminant, and right now let's plug in our discriminant into all known spot. We have x first and second equal to, we have minus b plus minus square root of discriminant and all over 2a. Really great. Equal to, right now we have minus b minus 10 plus minus square root of discriminant, so square root of 52, and we divide all of this by 2 times 1. Okay, right now let's simplify this real quick. We can easily do this because we have minus minus, we have plus, so we can write it as 10 plus minus square root of 52. We can write as square root of 4 times 13. Okay, let's write it like that, 4 times 13, and we divide it by 2. Right now, in terms of basic algebra property, so this property looks like that. I'm going to write it on the left side. When we have square root of a times b, we can write it as square root of a times square root of b. So we can easily like split it, but it works only with the multiplication and division, not with addition and subtraction, only with multiplication and division. So right now, let's split it. As a result, we have 10 plus minus square root of 4 times square root of 13, and we divide it by 2. Square root of 4 equal to 2, so we have 10 plus minus 2 square root of 13 all over 2. And there's like a really interesting trick, because when you have a common denominator, you can easily divide our numerator by 2, so we can easily look like split it. Okay, we can divide it by 2, and we can divide this part by 2. So we can write it as 10 divided by 2 plus minus 2 square root of 13 divided by 2. Okay, and right here we're going to cancel these 2, and right here we have 5. So we have 5 plus square root of 13. This is our answer, but plus minus, yeah, plus minus. So we have two roots to this equation. We have x first, let's write with the positive sign, equal to 5 plus square root of 13, and we have x second equal to 5 minus square root of 13. So we have two roots, but don't forget about a substitution in the beginning, because we need to remember that y equal to 10 minus x. And in terms of this, not like substitution, we express y in terms of x, and right now we're gonna go back, so we're gonna find our y, but we know everything about x, so we will have two pairs. So we have y first and y second. So first of all, let's find our y first. So y first equal to 10 minus x first. 10 minus x first, so we're gonna subtract from 10, we're gonna subtract this x first. So we have y first equal to 10 minus x first equal to 5 plus square root of 13. Yeah, we have y first equal to 10 minus 5 and minus square root of 13. So 10 minus 5 equal to 5. So we have y first equal to 5 minus square root of 13. So we have y first. And with the same principle, with the same algorithm, we're going to find y second. So we have y second, which is equal to 10 minus x second. And of course, it looks like we're going to have the same expression, but with different sign. Like we're going to have like a plus minus, and right here we're going to have minus plus, but everything can happen. So right now let's find the exact value. So y second equal to 10 minus x second equal to 5 minus square root of 13. We have y second equal to 10 minus 5 and plus square root of 13. 10 minus 5 equal to 5. So as a result, we have y second equal to 5 plus square root of 13. Yeah, as you can see right here, we have two pairs of solution, two pairs of roots. And right now, let's write our final answer to this question, and then we're gonna check real quick our roots. So we have x and y equal to the first x first. We have 5 plus square root of 13. 5 plus square root of 13 and 5 minus square root of 13. 5 minus square root of 13. And the second pair, so 5 minus square root of 13 and 5 plus square root of 13. Right now, let's check it real quick. Let's rewrite our expression from the beginning. So we have x plus y equal to 10 and xy equal to 12. Okay, this is our question from the beginning. Right now, let's check it real quick. First of all, let's check this addition, and we don't need to check both of these cases because we have addition. So 2 plus 3 equal to 3 plus 2, so it changed nothing when we like swap this by position. So we have absolutely the same expression, but with different like order: addition, subtraction, subtraction, addition. So it changed nothing in terms of addition. I would say I'm gonna underline that in terms of addition, it changed nothing. So as a result, we have 5 plus square root of 13 plus 5 minus square root of 13 equal to, need to be equal to 10. Let's see. So square root of 13, we can easily cancel it, and as a result, we have 5 plus 5 equal to 10. So addition works absolutely perfectly. Right now, let's find real quick a product, a multiplication. So as a result, we have 5 plus square root of 13 and 5 minus square root of 13 need to be equal to 12. Right now, if we look closely, we can easily multiply these parentheses by each other, but this is our school identity. If you know identity a square minus b square, this is equal to a plus b times a minus b, okay, a minus b. So as a result, we can easily consider it as a difference of two squares, because we have the same 5 square root of 13 square root of 13, we have plus minus. So this is exactly the same case, exactly great case to apply this identity. So as a result, we have 5 square minus square root of 13. We have square need to be equal to 12. Let's see what will happen. As a result, we have 5 square, we have 25 minus square root of 13 is equal to the power 2. Of course, we can easily cancel it. As a result, equal to 13 equal to 12. Everything is great. 25 minus 13 equal to 12. So our multiplication works absolutely perfectly. And maybe some students interested in approximately value, because we have 5 plus square root of 13, so we can easily get it through our calculator. I'm gonna write it right here approximately. This is a general answer to this question. If you see it in, for example, on your exam, this is a great answer for you because you don't allow to use a calculator. But maybe some students interested in approximately answer. So if we're talking about approximately answer, so if we're talking about pairs x and y, we are talking about the first pair 8.6 and 1.4. This is the first pair, and the second pair 1.4 and 8.6. So we are talking about approximately answer. This is our case. But if you see it on your exam, this is absolutely enough for you because you don't allow to use a calculator. So this is our absolutely correct answer. So I really hope you understand my explanation. I really hope you enjoy it. So if you do, I'm really glad about it, and I want to say thank you for watching. Thank you for supporting my channel. Thank you for supporting my content. I make more than like 500 videos right now, so I'm really proud of you that you watch my videos and maybe you learn something new. This is my main goal on my YouTube channel. I try my best to make new content every day, different content, like from Math Olympiad, from entrance examination, like different all the things. So I really hope you enjoy it. So write your thoughts. What do you think about this question in the comment below? It will be really interesting to exchange information. So what do you think about it? Maybe you know a faster method, maybe you solve it like in a few seconds, but I'm going to show you, I show you this basic method, basic school method in terms of like school algebra with the expression, the first expression, and then we're going to plug in it in the second one. This is like a basic method, and I really hope every student understand this explanation. So thank you for your time. Have a great day. See you in the next videos, and take care of yourself.